Welcome to Study Time, a televised home learning program produced by Rwanda Basic.
Hello, Senior 4 Chemistry students. Welcome back. Alan is my name, and I'm happy to still be interacting with you in chemistry lessons. We are still on Unit 15, which is about factors that affect chemical equilibrium, and that is under the subtopic chemical equilibrium. Please join with me as we go through this lesson. So, as usual, I have to highlight the lesson we are on. We are now on lesson 3, which I call part 3 because we are still on the factors affecting chemical equilibrium. So, this lesson is going to be focused much on the pressure changes and the effect that would probably be brought in by addition of inert gas for gaseous chemical reactions. And we shall conclude it up with the effect that is brought in by the presence of a catalyst. So we are going to be looking at those 3: pressure changes, addition of inert gas for gaseous reactions, and if there is any effect brought in by the presence of a catalyst. So we have our objective. I combined it and considered it as one because our focus will be on ammonia production from nitrogen and hydrogen. So as such, the objective is to explain how any increase or decrease in pressure and the presence of a catalyst affect the yield of ammonia, basically in the lab or even in industries. And that is our objective. So briefly, in a previous lesson, we looked at how changes in concentration affects the equilibrium. Then we used changes in the concentration of sodium hydroxide as regards to dichromate-chromate equilibrium. Then I left you with a related exercise, which I call exercise 2, or which I called exercise 2 because it was for lesson 2, and it is basically on the effect of changing concentration. And I included in the effect of temperature as we covered in lesson 1. So I left you with that exercise. I believe you attempted it. And if you did, let's now do a few corrections as what was expected of it. My emphasis will be much more on these action verbs: predict, explain. In other words, these bring about the whole idea of what is expected of you. Then equilibrium position. Those are the things we shall be looking at as we do the corrections. So let's do the corrections. I've left the introductory part not big or not much necessary. Predict and explain the effect on equilibrium position when small amount of potassium bromide is added. So in this case, when you add potassium bromide, it brings in the bromide ions, these. So what the first aspect that will occur, or the first consequence that will occur on addition of potassium bromide, the bromide ions will increase because this ionizes. So it will bring in bromide ions, making the reactant side, as you see my highlighter, the reactant side will be in high amounts than the product side. And that will disrupt the equilibrium. So how will the equilibrium modify itself to minimize that change? That is what the question is saying. So in answering, we must state our prediction, then go ahead and explain. So what will be the expected answer is the equilibrium shifts to the right. Why? Because addition of the bromide increases the amount of bromide ions, making this side to be higher in amounts than this. To balance it up, some portion of this side will move to this side, and that is why the equilibrium shifts to the right. More bromine and water will be produced to counteract the increase in amount of the reactants. So in that way, some of the reactants will form the products, and that is expected response. So, number 2, a small amount of sodium hydroxide is added. Remember, when you add sodium hydroxide, it brings in the hydroxide ion, which will react with hydrogen ions, producing water. In this case, the amount of water on the product will be high, but the overall amount of the reactants will be low because of the removal of hydrogen ions. So, in that case, to balance up the equilibrium or to minimize the removal of hydrogen ions, these have to ionize, bringing back the hydrogen ions at equilibrium. And so what will be the effect on the equilibrium position? It shifts to the left because these have gained up in amounts due to more water, so they will have to ionize to produce hydrogen ions. And that is how you simply balance. Common, simple balance. When this is high, amount of it will have to be removed to increase the amount here. When this is high, amount is decreased to increase the amount. So it is just a matter of balancing. And the last question, as we conclude up on that, is on temperature system. The temperature, basically, it's to know whether you have a negative value here or a positive value here. If you have a negative value, that indicates the forward is exothermic, the backward is endothermic. If you increase the temperature, you favor the backward. So that shifts the equilibrium to the left. So the point I need to emphasize as you're answering or as you're attempting queries of this category, state your prediction, state your statement, state your idea, then go ahead and explain it. So that is it with the review of the previous work in terms of changes in concentration and temperature changes. Now we are heading on to our third stress or our third factor, which is pressure, changes in pressure. So, one condition you need to understand, changes in pressure are not highly considerable when it comes to liquids or solids because the effect there is negligible. So much of the time, pressure affects reaction in gaseous form or in gaseous mixtures. And so in this case, we are going to be looking at two laws, Boyle's law and Avogadro's law. Remember when we started this unit, I told you I implore you as our upcoming scientists to try, be enthusiastic in science, do experiments, set theories and prove them, so as in future, your name can also be named against your law or your theory. Remember that? Now you see we even bringing in Boyle's law, Avogadro's law. So these are the people who experimented. So it is a call unto you. You are the upcoming scientists. I want you to try all your best and also set up a hypothesis or a theory. So let's come back to how these laws are connected up. Let's first deal with Boyle's law. A quick understanding. Boyle's law says that provided you maintain temperature constant, pressure is inversely proportional to volume. Well, let's illustrate this. You see temperature is maintained at 300 for this case and here 300. Pressure is moved from 1 to 2. So as you increase pressure, what happens? The volume has halved from 4 to 2. You notice that. This is for gaseous. So when you exert pressure on the gas, the volume they've occupied, or the volume occupied also decreases. So that is Boyle's law. Pressure is inversely proportional to volume for the volume occupied by the gas molecules. Increase pressure, the volume occupied decreases, as you see the illustration. Now, let's move to Avogadro's law. For him, he said, provided you maintain temperature and pressure the same, equal volumes of all gases will contain same number of moles. This is the crucial part. Equal volumes of all gases contain the same number of moles, provided temperature and pressure remain the same. Let's look around here. In our illustration, the blue balloon has helium, red has oxygen, green has nitrogen. They have different masses, nitrogen 28, oxygen 32, because this is a dimolecule, and helium as a single atom, it has 4 grams. But because they are at the same temperature and pressure, 1 atmosphere and 273 Kelvin, this is basically at 0 degrees Celsius. Same temperature and pressure. They will occupy the same volume. So, in that case, we can finally make a conclusion in there, or an inference. For Avogadro's law, the number of moles of a gas is directly proportional to the volume they occupy. Increase the number of moles, even they will occupy a relatively higher volume. Now, let's now combine Boyle's law and Avogadro's law. Boyle's at the same temperature, pressure is inversely proportional to the volume occupied by the gas. Avogadro's maintain same temperature, the number of moles they will occupy is similar. Same number of moles will occupy a similar volume. So in this case, we can relate pressure with the number of moles. And that is where pressure comes in to have an effect in equilibrium for gaseous molecules. And let's see how that exactly comes in. So when you're looking at the effect of change in pressure, you look at whether there is a decrease or an increase in volume. And how are they related? How are they related with the other laws that we've just talked about? Let's look at this case. An example is ammonia. Look at the example of ammonia here. Nitrogen has 1 molecule. Hydrogen has 3 molecules. So these 1 plus 3 become 4. So the volume they occupy is 4 because we've seen that the number of moles, they are directly proportional to the volume. I'm referring into using number of moles, converting it to volume. Point taken? So for the reactant, our volume here is 4 volumes. For the product, because the number of moles is 2, relate volume to number of moles, you'll get the volume as 2. Now you see where the other 2 laws are coming in. They come in to give us an idea of the volumes. And as such, we can connect them to the effect of pressure. Remember, for pressure to affect the equilibrium system, there should be either an increase or a decrease in volume. This specific example is decreasing from 4 to 2. I pause. So, if I can ask, how will an increase in pressure for that case affect the position of equilibrium? I need you to first guess, make a prediction, then we can discuss together. How would an increase in pressure affect the position of equilibrium in that case? All right, let's go and see. One thing to understand is, like as we looked at temperature, pressure also is considered in whether you have the forward reaction or the backward reaction. And as such, we bring in high pressure and low pressure. I'm pausing to take you a little bit back to temperature. Temperature, we talk in terms of endothermic and exothermic. Pressure, we talk in terms of high pressure and low pressure. So, as the way you see it, this is forward. We have 4 going to 2, indicating we are applying pressure. You are compressing. When you compress, the volume reduces. As you apply pressure, you're favoring the forward reaction because there is a reduction in volume. These gases have been compressed, so in this case, the volume has reduced. As you release the pressure, when pressure is low, then you favor expansion. So you will favor decomposition of ammonia to nitrogen and hydrogen. I think there you quickly see what we mean in terms of low and high pressure and how it affects the forward and the backward reaction. My quick mental question. So with the reason, how does a decrease in pressure affect the yield of ammonia from the above reaction? I had asked you that. I hope you have the answer. I'm giving you a few seconds to think through. If you look at that, you will notice that a decrease in pressure will favor backward reaction. But let's quickly go through this. So when you lower pressure, you shift the equilibrium to the left, because this is where we expect expansion of ammonia or the decomposition of ammonia, forming back nitrogen and hydrogen. Similarly, when you increase pressure, you favor the forward reaction. So equilibrium moves to the right. More of ammonia will be produced. To minimize the effect as the volume decreases. And this takes me finally to our last part. The quick mental work, the yield of ammonia will decrease. I think at this moment it is clearly indicated. You can really explain it. So before I leave to something else, I need to make this very, very clear. When you're given any aspect involving pressure, look at the number of moles. Do I have high number of moles? Do I have low number of moles? If I have high, this will be favored by low pressure because we need volume for these gas molecules to occupy. If I have low, high pressure because the volume will have reduced. As simple as that. That is for part A of pressure. Part B, if there is no change in volume. Just mental work also. If you decrease or increase, pressure has an effect. So if there is no any change in the change of volume, what will happen to pressure? Remember, Boyd is law. Pressure is inversely proportional to volume. Maintain volume constant, pressure will remain constant, right? Or maintain pressure constant, volume will remain constant. Yes? Mental work. So how if you have a reaction without any change in volume, will pressure have an effect? Automatically, no effect. And as such, no effect on equilibrium because volume is constant. Pressure is not changing. It is remaining constant also. And that is it. Simple. Isn't chemistry simple? Some of you are biased that science is hard. No, it is not hard. Look at that. Very, very simple. So let's conclude up. Increase in pressure shifts the equilibrium position to whichever side of the equation that has fewer gas molecules. Fewer gas molecules. Compress, you will reduce the volume, and so you will favor that direction. I enjoy science. I hope you enjoy it too. So let's go to one other aspect, adding inert gas on the position of equilibrium. What will happen? Of course, inert gas, as we looked at, they are the non-reactive elements in the periodic table, helium, argon, and so on. And because they are non-reactive, they do not take part in the reaction. What happens? They only affect the volume. Because they are gases, they will exert an effect on the volume. So the volume will increase. As it increases, to minimize that aspect, the equilibrium moves to the side with higher volume, or the number of moles. Let's take an example. That is for you. If you add argon in that case, this is left-hand side, this is right-hand side. What will happen? If you add a gas molecule, argon, where will the position shift to? The right, because this is having more volume. 1 plus 1, this is 2, this is 1. As simple as that. Don't you see? Very, very applicable and very, very simple. So let's look at the catalyst, presence of a catalyst. How does a catalyst affect the reaction system? They do not have any effect, and why do not affect is because they increase both the forward and the backward reactions equally. So there will be the amount in products that is being formed will be equal to the amount that is being converted back. That's what we mean by both forward and backward reaction equally. So they do not affect the equilibrium position. However, they increase the amount of equilibrium products. They increase the yield of, they do not increase the yield of the product. So the same amount of the product is formed, but just in short time. So that is quickly what we can look at in terms of the pressure, catalyst, and the addition of noble gas. Let's quickly summarize up the lesson. First, effect of pressure. So when you increase pressure, the equilibrium position shifts to whichever side that is with lower number of moles for the gas molecules. That is point to take note of. And if there is no any effect, or if there is no change in volume, then the pressure will have no effect. Secondly, inert gas. What they do, they only affect the volume of the equilibrium composition. And so they shift the equilibrium to the side with higher volume. Of course, that is to accommodate the added gas molecules. Next is the presence of a catalyst. What does not have effect on the equilibrium position, but simply makes the reaction very, very faster. The yield is attained at a faster rate than if you do not have the catalyst. But in terms of equilibrium position, no effect. So, as usual, I always leave you with the exercise to check your understanding. And as I told you from the start, it is much more on the production or the formation of ammonia. So we have this question. We are having temperature and the pressure, then and the amount, the percentage of ammonia at equilibrium. So we want to find out, predict and explain your reasoning, what will happen to the percentage conversion of ammonia if pressure is increased as you maintain temperature constant, or if temperature is increased as you maintain pressure constant. And if you add the the catalyst, in this case, iron. What will happen? These 3 questions should enlighten you so far on the factors that we have looked at. Thank you for taking part in the lesson. I hope you learned something. As I always say, science is simple and even applicable. All you have to do is just like it. You will use just simple mental knowledge or mental ability, then you are done with science. Thank you. Stay safe. I want to see you in the next lesson. Bye. Alan is my name.